So hello everyone, I'm Nathan, Business Development Manager at SilcsBio, and we're excited to welcome you to our CGenFF web app launch webinar. So I'm joined alongside application scientist at SilcsBio, Abhishek Kanoli. So for those who aren't familiar with what SilcsBio is, we're a company that produces computational chemistry software for drug design researchers. So CGenFF is one of our programs, but we also have something called Silk Small Molecule, which is for small molecule drug design. We also have something called SilcsBiologics, which is for protein-based therapeutics design. So we're excited to launch the CGenFF web app and extend the capability of our already existing CGenFF program. Let me start the slideshow. Let's first take a look at the agenda we're going to go over today. So first, I'm going to go over a presentation about what CGenFF is, the applicability of it, the history of the program, how it started in the McCrell lab, and how the program actually works behind the hood. And then I'm going to talk about what we're here for, which is how we extended those CGenFF capabilities to that web app version. Next, I'm going to go over a demo. I'm going to show you how to upload a molecule, generate in parameters, etc. And then we're going to have a Q&A session with our application scientists. And no need to wait for the Q&A portion to start populating those questions. You can just put them in the Q&A box at any time. Let's first do an introduction on what the CGenFF program is. So CGenFF stands for Charm General Force Field. It's a program that allows you to model the behavior of small organic molecules by understanding their parameters. So things like atom connectivity, atom charges, atom types, bond angles, dihedral angles, bond force constants, and all those different empirical force field parameters that are required for different types of molecular modeling methods, like molecular dynamic simulations. So on a fundamental level, imagine trying to understand the interactions between the atoms that are in a molecule at that molecular level. So those parameters that I mentioned, those parameters describe how atoms within these small molecules interact with each other. So once you know this in turn allows you to understand the molecule itself on a fundamental level, and then run those simulations based on the knowledge of this molecule. So next, let's talk about the capabilities of the CGenFF program. So you can see on the slide, the first capability, it can be used for over 90% of drug-like molecules. So CGenFF is based on the Charm force field. And we saw that with that Charm force field, it wasn't as applicable to drug-like molecules. So the goal of CGenFF was to expand the applicability and be able to use this force field in more drug design research. Second, easy to use. So it's a pretty simple process. You just input your molecular structure in Mol2 format. CGenFF does its work on the small molecule, and then it outputs those parameters that I listed. And then compatibility. So the output format is compatible with Charm force field and different types of modeling and simulation packages. For example, GROMACS molecular dynamic simulations. And it's fast, so it's pretty instantaneous. You just upload that small molecule. CGenFF does the work, and then within second, you get the parameters. And scalable. So with our desktop version, it's scalable to where you can upload hundreds or thousands of small molecules at once and instantaneously get the parameters for those ligands. With the web app, however, you'll have to upload one at a time, and I'll show you that during the demo. And there's also some other capabilities in our 2024 that we had in our 2024 release that aren't listed here. But one is we have a covalent module. So it's basically CGenFF for covalent ligands, so parameterizing those covalent ligands. And then we also have a built-in MD simulation module for more just efficient workflow calculations. And that MD simulation model is run on GROMACS. So next, let's talk about the applicability. So the main use of CGenFF is for drug design and development. Like I said, CGenFF was created to extend the capabilities of that original Charm force field to be able to include more than 90% of drug-like molecules. So on fundamental levels, CGenFF will give you those parameters that will help you predict how potential drug molecules will interact with a target. So for our customers, mostly what they use it for is to generate parameters for a ligand so that they can run a good MD simulation with a protein ligand complex. If you're not familiar with MD simulations, they serve a variety of purposes. One that we see a lot is understanding the structure and conformational changes that a certain small molecule will cause a target to undergo. But without accurate parameters for that small molecule, you won't be able to run a great simulation that will produce meaningful or accurate results. And this can also work for lead optimization too. So when you make a modification to a certain small molecule, whether you take out some atoms or add some functional groups, et cetera, you can run that modified small molecule through the CGenFF program and be able to see how that modification changed certain parameters of the molecule. So those are just some of the applicabilities of the CGenFF program that we see. Next, let's talk about the history of the CGenFF program. So this was the first paper on CGenFF back in 2010 out of the McCrell group. And, like I keep saying, the idea behind CGenFF was that we want to extend the capabilities of that charm all-atom force field, that original charm all-atom force field. We want to extend those capabilities to include drug-like molecules. So this paper introduces that charm general force field, aka the CGenFF, which expands upon that widely used charm additive all-atom force field. So that original charm force field, it primarily covered parameters for proteins, nucleic acids, lipids, and carbohydrates. But CGenFF extends its capability to encompass all those drug-like molecules. So the motivation behind the CGenFF is we wanted to enable simulations of a broader range of chemical groups that were found in both biomolecules and drug-like compounds. And this paper details what that philosophy is for parameterization. So it's a mix of quantum mechanics, experimental data, experimental validation, and theoretical models. So how it works is we have a certain data set that we have acquired through those three methods I listed, and that's basically in our program. When you upload your molecule, what we're looking for is a similar match to give you those parameters. So it's a relatively accurate based on the match in our data set. And we validated this through experimental validation. And then a major advantage of CGenFF is that it's compatible with that existing charm force field. So you can have those comprehensive all charm simulations of those drug target interactions. So people who are familiar with charm, they definitely love to use CGenFF since it's compatible. So next, let's talk more about the history. So we've already seen the impact of CGenFF in the past 14 years since that paper came out. It's already been cited over 10,000 times. You can see all the different papers and all the different citations on the right in Google Scholar. And that doesn't even mention all the Fortune 500 and startup pharmaceutical companies that currently license CGenFF. We've also had 35,000 unique users in both academia and industry. So we know that this force field is validated, and a lot of people trust it for their different drug design research. So let's talk more about how CGenFF actually works. So like I said, the parameters in our data set through that paper, they're derived from a combination of quantum mechanics calculations, experimental data, and the theoretical models we use. How it works for you is you upload that mol2 format or that ligand in that mol2 format you can see on the left. That's the input. The CGenFF program runs that molecule, and under the hood, how it's working, like I said, it's basically matching a relatively accurate, it's matching what's a similar molecule in our data set to the molecule that you uploaded. And that's how it spits out those parameters. And like I said, those parameters are, atom charges, bond lengths, angles, non-bonded interactions, etc. But the main premise is that it's comparing the molecule that you upload to a known data set. So what the main premise of this launch is we already had the CGenFF program for 14 years. We've already been licensing it as a desktop version. We also have people in academia using it as well. But why we're launching this web app specifically is that we want to make this program accessible to everyone. So instead of needing to buy a full license to use the CGenFF program or be part of academia, you can just create an account and pay per molecule. So maybe if you only have one molecule you want to run the whole year, buying a license wouldn't make sense. You can just pay per molecule and see, as needed. We also saw this was a demand because there's a lot of drug design researchers who are just doing preliminary work, especially at startups, and they maybe don't have the justification to get a full license yet because they don't know how their target will progress. So if you're in that boat too, then it's easy to just create an account and pay per molecule as you need it. But the main goal of this web app is, we saw that CGenFF was, being used extensively in industry and academia, but there was a segment of users who weren't able to use the program because they couldn't justify getting a full license. So this pay per molecule option is a way to fix that problem. That's a presentation on what CGenFF is and our web app. Next, I'm going to go over a demo that's going to walk you through how to use the web app and what the user interface looks like. Stop sharing. Yeah, so first to get to the actual web app, you just go to CGenFF.com and they'll take you to this landing page. So the landing page has an about section, contact us if you have any questions. There's actually a demo video that you can click on this third point. You can log in here and then you can also create accounts. So let's go to the create account section. And there's two different options. There's an academia account that you can create. So this is if you're part of a single lab at a university and using CGenFF for purely academic learning reasons. And then you have the second option, which is industry. So that's going to be for industrial users at companies and also for nonprofits. But you create that account and then you can log in and it'll take you to, and once you log in, it'll take you to that home button. So firstly, you can quick start. So you can either upload the file of the molecule through this quick start button, or let's just go to the start CGenFF job. So this will also give you like a breakdown of how to run it. But first step, run CGenFF. So first you have to have that mol2 file. I have one in my downloads page. So I'll just click on this and upload mol2 and choose options. All right, so firstly, notice how you can actually see the molecule and you can rotate it. This basically is done as like a check, a helpful check that allows you to just make sure that you actually uploaded the correct molecule. So next, gonna type a job name. I'm just gonna call this test case. And now you see all these different settings. So output mol2, that's basically gonna generate a process mol2 file of the molecule after assigning your parameters. And the atom names will be modified in accordance with that charm formatting. And you also have warnings. So this is just going to display any warning information that results from the CGenFF program execution. And then debug info, that's just the debugging information. So based on those warnings, what's the possible bug fixes that you could implement? And then copy existing params. That's going to copy the existing charm general force field parameters to the output. So you can, usually we choose to leave that off, but you can leave that on if you want. But this looks good. My molecule looks exactly like how I want it to be. I have all these settings completed. I've created a job name. Next, I'm going to process that input. All right, so once again, you can kind of move around the molecule, just make sure this is the molecule that you want to upload. And you can also see different job info for it. So you can see the options I selected, the name, what the file name is. You can also see the cost to run the job before you actually pay. And you can also see the param penalty and the charge penalty. So this is 50 or less. So I'm good with this penalty score. Next steps after taking a look at this would be to pay and run the CGenFF engine. All right, so I'll put a fake card in here so I can show you how to pay. It looks like there might be some mixed information, but we can just go through here and I can do this. Yeah, so okay, once you pay, you run the CGenFF engine, and you're going to get all these different results. So you first have the results stream file that you can see here. You have the log file. You can click on viewing there. You have the actual job info talking about the penalty and the options that you selected, and then this mol2 file. So you can download the CGenFF results directly here, or you can actually convert it to GROMACS and download those results in GROMACS format. So if you're trying to run that MD simulation with GROMACS, then this would be helpful as well. So that's a breakdown about how to run the program. And just to quickly go over the stuff in the left panel, you have your job history here. So say I didn't convert to GROMACS initially, you can convert it in the job history as well. And you can also see all the different, you'll be able to see all the different files that you can download based on that job that you ran. You also have a user manual here. This is another way to look at a tutorial that will walk you through the steps of how to use the web app. And then you have FAQ. So these are common questions, maybe like more common errors that you might see from uploading your molecule. They're answered here. But if one of your questions is not answered here, you can just contact us in this still need help section. You can also see your account settings. So how many jobs I ran this week in my institution, etc. And then another contact form page, and then feedback. So we definitely encourage you to use this feedback button if you have any ideas for changes we can implement, etc. That will help us when we inevitably update our website user interface. So that's a breakdown of a demo of how to use the platform. Like I said, if you have any questions still, you can always reach out through the web app. So next, we're going to do a Q&A with Abhishek. Let me just see the questions that are in the chat right now. Okay, first question is there a significant difference between the web app version of CGenFF and the desktop version?
Yeah, that's a good question, right? So the core functionality of generating the force field parameter remains consistent between both web app and the desktop version. So basically, web app is offering you, enhanced accessibility and ease of use, removing the need of, local installations. But there may be, other benefits of using desktop version, like a flexibility or adding it in your workflow or something. So but at the core, both functions like programs are same.
Yeah. Okay, next question is, are there specific molecules or systems that CGenFF is well suited for?
Yeah, so typically CGenFF is well suited for small organic molecules, drug-like molecules, especially those that are not covered by the existing force field. So it basically excels in parameterizing the novel compounds, but other than that, sometimes similar kind of organic molecules can be found in other fields. So sometimes like fields like material science or agrochemicals, or some understanding fundamental biological processes can be studied with CGenFF.
All right, next question is, can CGenFF be integrated with other simulation softwares or platforms?
Yeah, so CGenFF parameters are compatible with the charm force field, making it straightforward to integrate with simulation software that is, supporting charm force field. So such as NAMD, GROMACS, OpenMM, and the charm program itself. So yeah.
Next question is, how frequently is CGenFF updated in terms of the molecules it encompasses?
Yeah, that's a great question, right? So since the publication of the paper, the number of molecules in the training set have been updated regularly, as a lot of people over the years have collaborated in developing new for force field parameters. So the macro lab works collaboratively with them and to update the number of molecules that are in the training set. So yeah, please keep we encourage users to just keep checking on the new papers and the CGenFF website for latest updates.
Okay. Now, one question is, can you specify charge states for particular atoms?
There is on the desktop version, there is an option to retain the charges of the atoms that you provide in the mol2 format. So yes, but users have to be careful about how the charges are getting retained. So, but yes, there is an option if you are using a desktop version.
Then I can answer this question. So it's asking, what is the average time to register an educational institution that's not yet in our database? So that time is usually a week. If you fill out that form, every Friday, we look over that form and verify academic institutions. Let me get next question. What do I do if CGenFF can't parameterize my ligand?
Yeah, so first of all, yeah, we are providing the log file and the debug information in the web app. So look at that. Typically, most of the errors come from badly formatted mol2 file. So if you go back and check your mol2 file, making sure all the atoms, atom types, bond orders are correct, then then you should get correct parameters. But some of the cases, such as certain functional groups or certain elements are not supported in the CGenFF, then you're going to get that error. So in that case, you'll have to go back and maybe understand what are the parameters that are not available. In that case, you will have to go back to something like FFparam, which is also available from SilcsBio for academic labs that can help you parameterize your molecule from scratch.
And then can you talk more about the penalty scores? This one specific question is asking, does this web version figure out all penalties on molecule charges in an automatic way?
So there are like three kind of categories of penalties that are provided. It's like 0 to 10 is a good analogy, 10 to 50 is fair analogy, and then above 50 you'll have not so good analogy, where a user needs to basically make a decision about whether they should go for validation of the parameter from scratch. So other than that, if you want to know how the exact penalty scores are calculated, you have to go and look at the paper that will give you more detailed information about how these penalty scores are calculated. Does that answer the question?
Yep. And then this next question is asking, which tools do you suggest for mol2 file generation? Have you ever heard of Avogadro? I'm assuming that's a mol2 file generator.
Right. Yeah. So you can definitely, I think, use Avogadro to generate the mol2 files. That is open source. So yeah, that should be a good start.
Next question is, does the web app version of CGenFF support batch processing or automated workflows for large scale simulations?
Uh, no, simple answer is no, but that's a good question, right? So if you're interested in doing batch processing, or like you're building a workflow where you would like to, get CGenFF parameters for your small molecules, then you'll have to get the desktop version of the program, since the web app version only allows you to upload one molecule at a time. But we will think about adding that facility in the future, depending on how many users request that. But you can basically contact us at info@silcsbio.com and request for the desktop version that can get you started.
This next question is asking, how does this tool differ from ParamChem?
Right. ParamChem was just basically a program that was, it was not a program, it was like a funding program that brought different collaborators together to generate or to make this CGenFF program. And it was put on the website paramchem.org. So as such, it is the same program that was running on paramchem.org. So yes, I hope that answered the question. And FFparam is a different program that basically will help you parameterize molecules from scratch.
So this is a pretty specific question, but it's saying he has a molecule that has a 4-carbon ring. He got an error saying that double bonded 4-member ring is not supported. Do you have any suggestions? I would think that would be something FFparam would be helpful for, right? But
right, exactly, yes. So there are certain functional groups that are still not supported in CGenFF, and as I said, like there have been efforts going on to add a whole lot of more molecules in the training set. So at this point, you'll have to fall back to something like FFparam to generate your parameters.
So we have time for one more question. How private are the molecules I upload to the web app?
Yeah, privacy is indeed an important concern, right? And your question is very relevant. The privacy of the uploaded molecules is our top priority. The web app employs security measures to ensure that the user data is protected. Uploaded molecules are typically stored in a secure environment and are not shared with any third parties. Users can review the privacy policy and terms of service for detailed information on data handling practices.
Sounds good. Yeah, so that's all the time we have for this webinar today. For the questions I wasn't able to get to, I'll send you a personal email answering that question. But appreciate everyone's time. Like I said, go to CGenFF.com to actually use the web app. But if you have any questions, you can also contact us through that web app. But thanks for everyone's time. See you.